What's up guys, Onmaths here, and we are looking at straight line graphs. So we've got a semi-simple one to start off with, and then we'll have quite difficult ones for the second and third question today, since this is the higher paper. So first up, it's given us a point from this Edexcel, and this is from the mock papers they released before the new GCSEs started. And it asks us to find the equation of a straight line with a gradient of 3. So what does gradient mean? Gradient means for every one we go across, we go up 3. So that would be 1, 2, 3. Now you can probably see a problem here, is that the graph kind of doesn't go up any further, like that's kind of off the graph. So we change the rule slightly, and we change it to for every one we go left, we go down the gradient. So 1, 2, 3. Simple as that. Do it again. 1 to the left, and we go down the gradient. So 1, 2, 3. So we've got 3 coordinates now. And so what we want to do is we want to draw a straight line that's joining them all up. Easier said. There we go. So that's the line, but the question doesn't ask us to draw the line, it asks us for the equation of the line. And to do the equation of a line, we use y equals mx plus c. Now we need to know what each of these bits are. The m is the gradient, which it gives us in the question, and the the c is the y-intercept. Now, what is the y-intercept? The y-intercept is where this line crosses the y-axis, which will be this point here. So let's write that down. So y equals the gradient, which is given in the question. So it's gradient of 3x plus c. Now what is c? The y-intercept is -1. So it would be plus -1 or just -1. So the answer is y equals 3x minus 1. So make sure when the question asks you for an equation, always make sure that you write an equation, not an expression. I can see some students writing down just 3x minus 1, but it does ask for an equation. Next up, we've got AQA's offering, and this question doesn't give us a graph. In fact, the next 2 questions won't give us any graphs, but it will give us the coordinates. And it's the same idea, but you've got to be able to visualize it in your head and remember the formula. And there's a definite formula for question 17a, and that's the formula for a gradient. So let's start by writing that. So gradient equals change in y over change in x. Now some students get these muddled up because in school you always remember that x comes before y, so some students put x at the top, but this is definitely change in y over change in x, so you've got to remember that the formula. Just make sure you remember it. Right, so it's probably easier for us to work out the change in change in x first. So we have a look at the question. So x is 4 there, and 2 there. So it's gone from 2 to 4. So just figure out how we'd work that out. So it's gone from 2 to 4. So what we want to do is 4 minus 2. Okay, and that tell us what the change in x is. It's changed by 2, right? 4 take away 2. Do the same for the other one, for change in y. It's just there's a lot of negatives here. So change in y is -9 take away -5. Okay, so let's see what that equals. So again, we'll do the bottom one first. And so this is going to be 4 take away 2, which is 2. Then that's -9 take away -5. So 2 minuses make a plus. So it's -9 plus 5, which would be -4. then that's minus 4 divided by 2. So a negative divided by a positive is a negative. 4 divided by 2 is 2. And we know we've got that right because the actual question says show that it is minus 2, and we have done. Now this next question is quite fiddly, because if you were given an equation like y equals mx plus c, you would just put these two values in as y and x and see whether the left hand side equals the right hand side. But we aren't given the equation. Now one thing we can do is work out what the equation is by finding the y-intercept and writing an equation, but there might be a quicker way. So we know the gradient between a and b is minus 2. Okay, so you can imagine that as a being here and b being here, and the steepness of that line is minus 2. Okay, it looks about minus 1 with my little sketch, but whatever. Okay, so we're trying to see whether c, no pun intended, is also on that line. So we're trying to examine whether c is also on that line. So if the gradient between a and b is minus 2, and the gradient between either a or b and c is minus 2, then c must be on the line. So we're going to check. I'm going to have a look. B is bigger, so I'm going to pick A. It doesn't really matter, you could pick A or B. And if we find out the gradient between A and C is also minus 2, C must be on the line. And that is a very, very good proof. So we're going to copy the coordinates to A, which is 2 minus 5. So A is 2 minus 5. And we've got the coordinates for C. So I write down the same equation as I used before. So gradient equals change. In fact, we could just use this symbol, change in y over change in x. And in science and mathematics, that triangle means change in. It's a Greek symbol. Delta, which always means change in. Okay. So the change in y, and it doesn't matter which way around we do this. We could do the a coordinates, take away the c coordinates, or the c coordinates, take away the a coordinates. I'm going to do, I don't know, c coordinates, so 601, take away the a coordinates, so take away minus 5, over. And as long as you make sure you do the same one, so if I'm writing down the c coordinates first, I've got to do it on both the y and the x. So minus 2. Okay. 601 minus minus 5 is just add. So 606. Minus 301 take away 2 would be minus 303. Positive divided by a negative is a negative. And you can see here 606 divided by 303 is obviously going to be minus 2. And that's absolutely fine as a proof. I think some students, when they do this, think that they've got to work out the equation and then do it that way. You don't need to. If 3 points all have the same gradient as each other, like relative to each other, then they are absolutely on the same line. Now, if we worked out, I don't know, the gradient between C and another point, like D, and it was minus 2, that would not be a proof, because that just shows that they have the same gradient. So A and B have a gradient minus 2, and then C and D have a gradient minus 2, but there's no proof there. But if I show that the gradient between A and C is minus 2, which I have, and the gradient between A and B is minus 2, then C and B must be both on the same line. Now, you wouldn't lose any marks if you worked out the actual equation of the line. In fact, you'd get full marks, and that would be fine. It's just not as quick, and that's why we've done it this way. Now, I have said this in previous videos, and I will say this again now. You risk only getting 1 mark on this question if you leave it as it is, because the question asks you a question, right? Does C lie on that line? And we haven't answered it. So we just need, probably for this, to say yes, it does, or just yes. So you need to make sure you actually answer the question. For questions that like this one that say show that, well, we have shown that. We don't need to answer the question, but when it asks you a question, make sure you answer it. Okay, finally, we've got our OCR question, and this question's all about understanding perpendicular. So it's a really good question to end on. So we're given coordinates for P and Q, and sometimes, not always, but sometimes I do a little sketch just to help me visualize it. So in this question, it says we've got point P, which is at 0, -1, which is there, roughly. That'll be -1. And probably should put P on the other side, really. So put -1 there, and then P. And then Q is 5, 9. So Q is up there. Okay, and that's at 5, 9. Right, and I'm not going to use this this little sketch to prove anything with these questions. They want it done kind of algebraically or mathematically, written method. But it's just maybe sometimes helpful to visualize what it's asking. So it says find the equation of the line through P that's perpendicular to line PQ. Now perpendicular means at right angles. So it's a line that's going to look something like that. Okay, and that's going to be a right angle there. So that's what we're looking for. So the first thing, whenever you're working with perpendiculars, there's a rule that says that the if you multiply two gradients that are perpendicular to each other together, you get -1. Okay, and we're going to use that rule to work out what the gradient of the perpendicular line is. So it's when you're looking at perpendicular lines, you have to have a gradient to work it out, because if we know what that gradient is, then we can work out what that one is. Simple as that. So let's work out that gradient, and we've been doing this a lot today. So the gradient for line PQ, so I should probably write down here PQ because that's what we're working out. It's changing y over changing x. We're well versed on this now. So it would be 9 take away -1 over 5 take away 0. 9 take away -1 would be 9 plus 1, which is 10 over 5, which equals 2. So M1 is 2. Now, you can use this formula, or you can remember a kind of trick way of working out the gradient. Okay, so for perp line, perpendicular line, we can work out the gradient by doing two things to the gradient of PQ. So the first thing you've got to do is you've got to find the reciprocal. Now reciprocal is, and this isn't anything to do with the question, but reciprocal is when you flip them. And so if you've been doing division or anything, you know how to find the reciprocal. Okay, whenever you've got a number like 2, 2 is actually can be written as a fraction, 2 over 1. So when you flip it, it becomes 1 over 2. Okay, so it's 1 over 2, so it's a half. But you've got to do two things. Okay, first thing is you've got to find the reciprocal. Second thing is you've got to change the sign. Okay, you can see in our diagram on the left hand side that if the purple line's positive, then that kind of greeny blue turquoise color line will be negative. So if one line is positive, the other has to be negative if they're perpendicular. Okay, so if PQ gradient is positive, then the perpendicular one has to be negative, so it'd be -1/2. Now the question doesn't ask us to find the gradient, it asks us to find the equation. So we've got to actually find the equation. So we've got to do our y equals mx plus c. So y equals, well, the gradient is -1/2, so -1/2 x. And then the y-intercept is actually given to us in the question. If you look at the diagram, the point P is actually the y-intercept, so it should be -1. So it's y equals -1/2 x minus 1. I hope that video has been useful. If it's been useful, please click like. If you want to see more from us, we release videos every single weekday. That's Monday to Friday. at 9 o'clock in the morning. And please click subscribe to make sure you're up to date with it and make sure you get all of them sent to you. If you want to see more from us, go to our website, onmaths.com. There'll be a card that magically appears above. And there's loads of free resources. You don't need to sign up, but if you sign up for free, you save your scores and you've got access to our summer school. Thank you very much.